Welcome to today's webinar brought to you by Cambridge Semantics, DataVeil, and Denodo. I'm Stephen Fagg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Implementing and Managing a Data Fabric, Steps to Success. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question is not selected during the show, you will receive an email response. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we have Sam Chance, Principal Consultant at Cambridge Semantics, Tom Hoblitzel, Vice President of Data Management at DataVeil, and Kevin Bohan, Director of Product Marketing at Denodo. Now I'm going to pass the event over to Sam to get us started. Welcome to the broadcast, Sam.
Thank you, Stephen. And hi, everyone. As Stephen said, my name is Sam Chance, and my company is called Cambridge Semantics. We're based in Boston, and we offer the Anzo Knowledge Graph software platform, which serves as a backbone for data fabric and data mesh architectures. Today, I'm going to talk about implementing your data fabric using Knowledge Graph technology as the underlying data model. And I think is that choice is your key to success. The assertion is on this slide is that not all data fabric implementations are created equal in terms of information accessibility, usability, scalability, and adaptability. A shared goal of data fabrics, however, is easy to access information on demand. In other words, we seek to shift humans and software from transactional activities such as data gathering and preparation and aggregation to more cognitive activities such as analysis and insight creation. Toward that end, the data model becomes arguably the key determinant of success. I'm biased, of course, but based on my experience in this technology space, I think data fabrics built on W3C semantic web standards, namely Web Ontology Language and Resource Description Framework, also called OWL and RDF, will prove superior over time. These standards remove structural and format heterogeneity and add human and machine understandable meaning, i.e. semantics. OWL RDF-based knowledge graphs readily adapt to change in uncertain times due to what's called the open world assumption. That's a topic for another time, but you can research that concept. Further, information in semantic knowledge graphs is modeled and presented in business-oriented terms instead of physical schemas, which allows users to interact with information more aligned with how they think, and subject matter experts and all your users interact more intuitively with information. Also, OWL is machine understandable and enables machine reasoning services that create new facts from existing facts. Your knowledge graph should grow. Your knowledge graph, as it grows, represents everything you know. And at least with Anzo, it is made completely and arbitrarily accessible to answer known and unanticipated questions on demand. No indexes required. Knowledge graphs move more intelligence to the metadata, which makes data more interoperable and makes the software appear more intelligent. A concept that has increasingly gained awareness is the idea of data as a product. That is, we want to require data providers or publishers to take responsibility for curating and managing their data sets. Curated knowledge graphs can be logically and physically partitioned to represent different data products. Of course, knowledge graphs are aligned with the FAIR principles of findable, accessible, interoperable, and reusable. So this kind of depicts what we want. What we want is to take starting from the bottom, to take all of these different data systems, repositories, files, services, etc., and get rid of all of the different proprietary, or not proprietary, but all the different formats, structures, syntaxes, integrate that in a way that brings together information based on the meaning of that data. For example, you may have information about John Q. Public in 10 data sources, but the question is, what do I know about my customer, John Q? And what we want to do is make all of that available to end users and automated applications in a way that is more conceptual, fully integrated and seamless to the clients, be they human or machine clients. So how do we get there? This slide is, for better or worse, it's a little bit product oriented, but the idea is on the left, your input side is where you have all of your heterogeneity, aka the chaos, and you want to be able to bring that in, meaning you want to connect to it or collect it, however you prefer, and then begin to normalize that, in our case, into RDF, the graph, and I'm pushing knowledge graph as your foundation. So you convert those sources, the data or the metadata from those sources, into ontologies, the OWL metadata, and then you convert the data in those sources into what's called RDF triples. So now you have your initial raw knowledge graph representations, and then you apply standard or enterprise models, OWL ontologies, to link the auto-generated concepts and data into more intuitive, business-aligned knowledge graph representations. And then at the bottom there, you can see where you're blending the data. And this is where you might perform your ETL, your transformations, computations, etc. Maybe apply those inference services that I mentioned earlier. But then finally, you have these prepared data sets that can serve as your data products. And further on the right in data access, you can see on the top right, there's Anzo. Like I said, it's kind of a product slide, but this overall flow is not unique to Anzo. But you want to make available tools from your solution, your data fabric, but you also want to make available the ability for users to use their own preferred tools, so that you minimize the impact on them and help promote adoption. And this applies to unstructured too. Again, kind of an Anzo specific, but it's not just our product. The idea is that you want to be able to account for unstructured content as well. And in that second stage there, where we're saying configured annotators, it's basically an NLP function. And what you want to do is extract the entities, relationships, facts that you care about, and also represent them in the knowledge graph, and link that to your structured data through the ontologies. And the ontologies are the formal definitions of your domain or your application areas. But all of your structured and unstructured data is linked through the knowledge graphs. So let's get going. And a great resource to get started is if you are interested in knowledge graph as a foundation and using it as your, I'll just say, your premise, the Rise of the Knowledge Graph ebook provides a great conceptual and practical information with guidance to get you underway. If you're thinking about data fabric for your company or your team, you are already thinking big. I recommend starting with 2 or 3 data sets to create an initial knowledge graph. research commercial offerings so you're prepared to scale fast. And then depending on the scope of your project, you'll likely need experts to get you going in the right direction and minimize risk. And I'd say before you run around shouting the data fabric message, educate yourself. If possible, build your first knowledge graph based on a specific problem that you know others will care about. While it's true that one can create a knowledge graph using a text editor, this is tantamount to boiling the ocean. Again, an effective knowledge graph software platform will prevent you and your team from requiring specialized skills to be successful. It will also help you optimally focus your efforts, and it will provide the quickest and most likely time to value. When you develop your UIs, be careful not to just show these dense fuzzballs. People don't understand them or they don't care about them, but they can help people understand that the data is now highly connected. Anyway, figure out how to display the data from multiple sources in one view. People typically get it, especially end users, when they see data from all over the place being brought together in one logically consistent view in a single pane of glass. But a harsh reality is that some may not understand the significance of how you created your demo. They just might not get it. As such, it's important to find and engage people who will understand why your approach is so important. We're talking architecture, so users typically don't know or care. Your data fabric is something of a journey. You start with a couple of data sets, create your initial knowledge graph, then expand and iterate. It's very well aligned with the agile development process. And over time, your data fabric becomes the primary information access source. By the way, it's worth mentioning that your data fabric should not disrupt current operations. It should be an overlay of existing investments. Additionally, it should allow end users to continue using their preferred tools, like I mentioned earlier, perhaps in addition to some you might provide. As we mentioned earlier, treat your data as a product with quality metrics, service level agreements, change management processes, and so on. In contrast to early and even some contemporary data architectures, we are intentionally thinking about others and how we connect to the larger community or network of information. So think more ontologically and model data based more on its inherent meaning, not based on known questions or known use cases. Consumers will customize it if and as needed. We publish a knowledge graph. We published a knowledge graph best practices article on our website, which elaborates on all this stuff that I just said on this slide. And it has video and commentary as well. You might find that useful. Last slide. I wanted to say a word about large language models and knowledge graph. So probably a statement of the obvious, but generative AI is front and center now, but there are serious concerns with AI in general. In fact, it has some people calling for bombing data centers, all the way to other people saying they want to create an AI god. So you get the sense that you want to proceed, but you want to proceed with your head on a swivel and thinking about what you're doing. But the GIGO principle still applies. In other words, garbage in still leads to garbage out. And although the G in ChatGPT is generative, a lot of effort is going into generating the right context. So suddenly a spotlight is on knowledge graphs because, among other things, they are fully contextualized and provide great input for AI technology. In fact, if you research the semantic web, capital S, capital W, you'll soon discover it was originally envisioned for machines. As we will see soon, being able to explain outputs of AI as efficiently and as effectively as possible will be critical to competition and regulatory compliance. And superior knowledge graph implementations naturally support verification and validation functions. This is typically enabled by what we call provenance. So finally, in my opinion, data fabrics built using knowledge graph technology provide supercharged inputs for AI. In other words, knowledge graphs enable AI. And that concludes my presentation. Stephen, over to you.
Thank you very much, Sam. Okay, it's my pleasure to introduce our next speaker. Once again, Tom Hoblitzel, Vice President of Data Management at DataVale. Welcome to the broadcast, Tom.
Thank you, Stephen. So what I want to talk about today is really, I want to probably step back a little bit and talk about what is a data fabric and what it can do for you. When we start out with a data fabric, what we're really looking at is a combination here. You know, we've heard the terms data warehouse, which has been around from an analytical perspective probably over the last 30 years. You know, a data warehouse is really a repository for structured, filtered data that is being processed for a specific purpose. It utilizes the ETL side of the equation, the extract, transform, and load, to basically capture the data, load it into the environment, and make things work. Where we move into a data lake, which has become prevalent probably over the last 5 or so years, it's really a large pool of raw data that really has no use that has been determined. Many organizations are loading data into the data lake to determine what they want to analyze, how they want to analyze it, but also you can load structured and unstructured data where they can then go through that unstructured data, such as documents, pull out the information they're looking for, and really leverage that from an analytics perspective. And when we're talking about analytics, what we're really talking about is getting the right data to the right person in a timely fashion. Now with the evolution of the data fabric, what the data fabric is really doing is it's providing to organizations the ability to solve complex data problems and use cases by managing the data regardless of the type of application, platform, and where the data is stored. It's leveraging the metadata to access data that is within the organization to be able to seamlessly access that data, share it, distribute it, and it may be used for analytics or it may be used for integration of applications, but it really provides you an overall complex capability to move forward. So while the data lake and the data warehouse complement each other, you know, from a data lakehouse perspective, from an analytical perspective, the data fabric goes a bit further and complements such data platforms with applications to ensure the complete exchange of data in the company. So when we're talking about sharing data, many organizations are moving more towards the data fabric aspect because they're not looking at it from, hey, I need to understand what my data is, but they want to understand it and they want to share it, whether it's an application, whether it's an analytic environment, etc. So when we look at the data fabric, what we're looking here is really an architecture and a set of data services that provides consistent capabilities across a choice of endpoints spanning hybrid multi-cloud environments. You don't need to be in the same cloud. You don't need to be in the same environment. The data fabric provides the connectivity regardless of where your data source is. It's a powerful architecture that standardizes data management practices and practicalities across the cloud, on-prem, and edge device solutions. So you're not looking and saying, hey, I'm going to create just an environment that has to be single cloud or multi-cloud. What you can actually do, as the following example shows, is really bringing data. You know, your management platform, you're deploying data, your orchestration, your user experience, your content. You may have curation services, and you may have data hub components in AWS. It could be in Azure. It could be in Oracle. But what you're able to do is access the data throughout the organization through the data fabric. So when we talk about the benefits of a data fabric, it's really the first benefit is to consolidate data from multiple sources into a single platform. So you're getting the ability to provide data to the user as they want to be able to see that data and work with that data. I mean, let's face the reality. Many organizations are not looking to set up a whole structured organization from a data perspective. They want to provide self-service capabilities out to the user. So by consolidating the data into a single platform, users can access it, report on it, understand it, analyze it, but also be able to process that data and leverage it in artificial intelligence, machine learning, and other types of applications. So beyond consolidating it, you can process and analyze the data in real time. You can access it from anywhere, and you can scale data processing and analytic and analysis capabilities as needed. And this is one benefit of moving it to the cloud, is that you have that ability of scaling up and down as you require to be able to move things forward. So when we look at best practices for managing a data fabric, first you want to be able to do is really set up a data marketplace for your developers. You want to be able to deploy graph-based application or analytics to find correlations of the data, understand the compliance and regulatory requirements that you need to fit for your data. Obviously, in your financial services, in life sciences, you've got various compliance and regulatory aspects that you need to take account of. Where is that data? What's the lineage of that data? How you move forward? Then you want to proactively avoid building just another data lake. You want to be able to look at it from a data ops perspective, from a process model, to be able to integrate that data across the environment and move that forward. So you want to be able to join that data regardless, and there's a variety, as Sam was talking about, one application or one product that can do it, and I think Evan will talk about another one. It's really a matter of moving towards a data ops process model to be able to integrate data that exists within your enterprise and making that data accessible to really any individual within the environment. So when we look at the architectural components of the data fabric, you're looking at where is the data? What are those data sources? What's the analytics and knowledge graphs for processing? What are the algorithms for insight generation? And this is when we get into artificial intelligence and machine learning. We want to be able to generate insight out of the data that exists within the environment and be able to bring that forward. We may need APIs and SDKs for connectivity. We need to have a data consumption layer, a transport layer, and a hosting environment as part of the architectural components for the data fabric across the organization. If we look at it from a data fabric architecture, the elements, you really wanted to make sure you have an augmented knowledge graph. You want to make sure that that abstraction layer provides a common business understanding of the data. You want to make sure that everybody has a common definition. You want to get to that single source of the truth, not many different variations. And this is where data governance comes in. Data governance will help you provide that single source of the truth, that single component, that single understanding, that single data glossary that everybody can look at to get to that one version of the truth, and the knowledge graph will help that. You want to have intelligent integration to really extract, ingest, stream, virtualize, and transform the data based on your data policies. You want to be able to minimize storage and costs. You want to be able to move to self-service data usage where users can go out, understand the data, be able to move forward. But looking at what they have, be able to provide that data out to the user for them to be able to do their own analysis and work with the data. You want to have a unified end-to-end lifecycle around the data. So in management for composing, building, testing, and deploying the capabilities of the fabric. You want to have governance, and you want to have really, it wants to become AI and hybrid cloud ready. When we look at what use cases are out there for a data fabric, well, data fabrics are in their infancies. It's still early in the stage. It's not necessarily something that is being ingested by all organizations out there. Many organizations are looking at it, but really, as they get adopted, you need to look at the ability of really data integration, business and data discovery, and really looking at a variety of use cases. Those use cases may not be that different from other things that you've done. So for example, if I can integrate the data and bring the data together, I can be able to understand things that we've always tried to do around customer profiling, fraud detection, preventive maintenance, return to work risk models, really a variety of things that people are now looking at AI and machine learning to help them drive to be able to move forward. So the data fabric is here. It's the ability to bring data together in a single unified environment, and it's something that really can help moving towards a self-service capability. So thank you. Stephen, back to you.
Thank you very much, Tom. Okay, it's my pleasure to introduce our final speaker for today. We have Kevin Bohan, Director of Product Marketing at Denodo. Welcome to the broadcast, Kevin.
Thanks, Stephen. So what I wanted to do before jumping into explaining and planning for success around a data fabric is quickly do an introduction for Denodo. If people aren't familiar with Denodo, Denodo is a global leader in data management. We've been around for over 20 years. We were founded on the concept of bringing data together, providing a single view of that information without requiring the consolidating into a central repository, so making it easier to leverage distributed data. If there is a analyst report around the data integration, data management, or even data fabric environment, Denodo is considered a leader. But what I'm most proud of is customers. Our customers have consistently ranked us high. For the last 3 years, we've received the Gartner Customer Choice Award. So this is feedback from customers. We're the only data integration tool to receive that for the last 3 consecutive years. So it just as a quick background. So what I wanted to do is talk a little bit about the steps you can take to be successful, to have that success when you're implementing your data fabric. The normal life cycle that products go through, and Gartner talks around the hype cycle. In 2021, data fabrics were at the peak of inflated expectation. In 2022, they've slid down into that trough of disillusionment. That isn't necessarily knocking what the data fabric can deliver, but what it is vendors tend to overhype what capabilities are there. Then customers build up in their mind that it can even do more than the hype that the vendors might do. So what I want to do is focus on what are those things that you can do to make sure if you're embarking on implementing a data fabric, what you can do to be successful. And I want to look at this from 2 standpoints. What capabilities you might need, and then also how can you ensure that you set expectations correctly within your organization and that you show that you're meeting those expectations. So what I first wanted to do, because I just put up that whole hype cycle around inflated expectations and all that, is make sure that I'm clear. Data fabrics are real. People are getting real value from them. There was an article in the Wall Street Journal, I think it was just a week or 2 back, showing the value that Estes Express, it's a trucking organization dealing with transportation and logistics. What they were able to do by implementing a data fabric is they showed that so far, and they were key on that so far part. I'll get to that point later, why the so far part. But they saved 10% on the infrastructure costs and the labor related to the data and analytics initiatives. So when imagine most of the audience, they know how much they spend in the cloud and what kind of resources they put behind doing that. 10% significant. Another example around Sunbelt Rentals, they were able to deliver data products 62% faster. And they did that in a number of different ways. Implementing a data fabric made it much quicker than your traditional point-to-point integration with ETL jobs, building out an ETL pipeline. It also improved the speed at which their data scientists could access well-curated data. So the value from data fabrics are real. Customers are seeing that value in implementing it. So what can you do to make sure you get similar value and that you're able to show that value within your organization? A couple of recommendations. First, because there is that hype, whether it's coming from the vendors or trade journals within the industry or even just within your own organization around different capabilities, look for independent third parties to identify what capabilities you need. The table on the right was built for a white paper that we just recently created, and it should be published any day now, using a number of different industry analysts and the criteria that they built to identify what's needed around a data fabric. What you want to do is not only look at, specifically around a data fabric, but there's going to be other goals you might have around moving your infrastructure into the cloud, or something that I've seen with quite a number of customers is the data fabric is a step in them ultimately adopting a data mesh where they're distributing the ownership and the building of data products to distributed teams. So identify what different requirements you have for other initiatives as well. And that allows you to build your unique set of requirements. This is nothing new, and people understand that. But what I wanted to do is not necessarily, because I don't have the time for it, going through each of those requirements that are in the table, but talk about a few key ones because they are important. The first, and it's been covered by both Sam and Tom, is around the semantic layer or knowledge graph. That is a key aspect, because what you need to be able to do if you're going to gain value from your data fabric implementation is make sure that the information is easily consumable by those people within the organization that need the data. It's not just the people running reports, but it can also be or is the data scientists within the organization, but also your application developers. If you're coming up with a trusted source of information, you don't only want to make that available to the people that are doing analysis on the information, but make it available so you can make that information publishable to whatever application you're building, showing you the customers, to partners, whoever needs to access that information. And the knowledge graph is key, and I won't go into it in too much detail because Sam covered it in great detail, and I think he did a great job on that. But it's really about not just having the canonical models, but you have additional layers on top of it where you can present the data to the consumers in the format that they want. You might be presenting that same data to multiple consuming groups in different formats, and the semantic layer allows you to do that. And by doing that, it's going to make it easier for people to make use of the data, which is critical. One of the stats they have in the industry is around data utilization. And there was a survey where I think 62% of the respondents said they use less than half of the data that's available to them within the organization. And part of that, there's a number of different reasons, but part of that is because you're not necessarily presenting it to the people or making it easier for them to use, but they're not necessarily able to use it because they can't understand the information. The next part, a key aspect to the data fabric, is around active metadata. Active metadata is, we're all familiar with metadata, where it's going to be the information about the data. But this is also the information around how the system's being used. How are the different components of the environment interacting with one another? How are users interacting with the system to allow you to automate different tasks around data management? So active metadata will be used then by the data fabric to automate or augment different data management tasks. It'll be used by the data fabric to make recommendations on how to optimize the operation within the environment. So active metadata is really at the heart of what a data fabric is going to be able to do, because what you're really looking to do is to get that business value, and the augmentation of traditional data management tasks to make it more effective to deliver the information, to make it more efficient in doing so, and to free up time from your data engineers to work on more strategic initiatives is critical. Another part or a critical piece is the augmented data catalog. It's one thing to make that data easy to understand, but you also then have to make it easy for the users to consume that information. So a catalog allows them to have that experience, to be able to come and access data almost the same way as they would shop for other products. We talk about data as a product. The data catalog allows you to provide that ability for the users to come and browse and look for what interests them. A data catalog or augmented data catalog simplifies the process because it's leveraging the metadata and the active metadata to build out that catalog. So you're not necessarily required to manually do many of those steps. What's key is when the people are coming and finding the different data sets that might be available to them, is to make sure they have trust in that. So I think it was mentioned by Tom earlier, where around data lineage and understanding where that information that they're going to be using comes from, showing that within the catalog is key, showing that other users are using this data source and it seems to be a popular source of the information, allowing users to endorse it, saying, I use it. Just going back to that analogy of the online shopping, it builds the confidence in the users that are looking for this different information to trust that what they're going to be providing, or what, their project to use that information is using a trustworthy source. Another key aspect, because what you have data catalogs that are standalone, not necessarily part of a data fabric, but as part of a data fabric, that you're not only providing the ability for users to come and find the information, but you're also providing the capability to deliver that data as well. Is now what you can do is, by combining those capabilities, you not only allow for the definition of the different data security and governance policies, but also the enforcement. The execution engine that's providing the information to the end user after they run their query, and that allows you to, from a central location, because now this is the point that everyone comes to access information, you can provide a consistent set of security policies throughout the organization. A key part of what I spoke around with augmentation, that is the recommendations engine. And recommendations engine is going to do that automation, give you the ability to automatically detect what's going to be the most effective way to execute this query and provide the information back to you. What's the best way to optimize the environment? Should I cache certain data for frequently queried certain queries that'll allow you to then be more effective in executing them? Recommendations engine can make recommendations for those users when they come to the data catalog. So when you're looking at how to build out your data fabric, a key part is that recommendations, because that's where you're going to get that value. Look at what can be automated with that machine learning, the AI capabilities with inside of the different tools that you're selecting is a key aspect. And the next part that I want to cover is talk a little bit about that. How do you set expectations appropriately within the environment? And then also, how do you show the results? I was reading a report recently, and they did a survey. About 35% of organizations said that they were able to show business value for their data and analytics projects. That's incredibly low. We really have to do better than that. We have to focus on what's the value we're delivering. So first is setting the expectations appropriately for the for your project. As we talked about, and each of the vendors spoke about it, is a lot of this is based on the metadata or the active metadata that is happening. And you have AI and ML that's going to help automate some of these different processes. Like anything, the more information you have, the better the AI recommendations are. So it's going to take time to get to that full value and set that expectation up front. But also, what's key is to sorry, I'm on the wrong slide there. But what's key is to the key is to be able to show the value that you're getting from the tool, and does it have the appropriate dashboards in there to show the execution, how much resources it's taking. Now that most things are happening in the cloud and everything's metered, are you getting the value from what you're doing, or is there a different way to architect it using different cloud services? Like S3 is a lot cheaper than if you're running something in Redshift or if you have it in Snowflake. So having the appropriate DevOps, FinOps tools in place will allow you to show that value. So as I mentioned earlier, we are publishing a white paper that goes into a lot of the details and breaks down each of those 14 capabilities that I showed in the chart earlier. If it will be published shortly, but if you're interested in it, send me an email. I'm happy to make sure that you get a copy of that. But with that, what I'd like to do is turn it back over to Stephen.
Thank you very much, Kevin. At this point in time, we're going to dive into questions from our viewers today. So, Sam, the first question is for you. How do I combine data fabric and data mesh architectures?
Oh, great question. So first of all, we've been talking about data fabric, obviously. So a word about data mesh is it is based on what I've read and observed as almost as much about process and policy as it is about technology. And one of the large or key points in the mesh that is coming out is data producers or publishers being responsible for curating their data and offering it as a product. So that is not a technical thing, but it is implying that all the data publishers are all over the place. So you have this notion of distributed and maybe decentralized. And the data fabric is seeking to provide that frictionless access to all of this data. So then what you want to do, and this we have articles on this, of course, on the website and LinkedIn, is use the knowledge graph to be that connective tissue between both of those constructs, and more specifically, the W3C semantic web standards are built for distributed, decentralized. Hopefully that helps.
Absolutely. And Tom, Kevin, I'd love to get your takes on this as well in terms of combining data mesh and data fabric. Tom, any further thoughts on that?
No, I think that Sam pretty much covered it from my perspective. I agree with him with what he was saying.
Gotcha. Kevin, anything additional?
Yeah, I think I fully agree with everything Sam said, but what I would add to it is as you distribute the creating of different products, and then those products are going to be made available to other consumers, and then other domains might take products in, combine them, and offer it as their own product. You have to also think about how are you going to handle distributed data security and data governance. Is there a way that you'll be able to allow those teams to own that data product, but have a centralized way to ensure that you are effectively putting proper governance and security tools in place so the organization's protected and you don't have one team potentially exposing something that they shouldn't or don't have the property controls in place. So I think that's an important aspect on top of the knowledge graph.
Understood. That's a great point. Yeah. Tom, our next question was directed to you. Do you expect data fabrics to become common in the use for analytics?
I actually do. I expect the data fabric is here to stay. It provides the ability of integrating data across the enterprise. We've gone through an evolution where we had very specific solutions around data warehouses, data marts, that were tied to very specific analytics use cases. And then we've moved out to the data lake, providing structured and unstructured data that can be moved around and be analyzed and be decomposed to provide capabilities around that. Now, as we move into a data fabric, it's really the integration of data throughout the enterprise. And that ability really provides new capabilities from an analytical sense to the users and to the business. Instead of the business having to worry about IT, through the data fabric and through the metadata that's out there, they can access data that they need, how they want to work with it, and how they want to move forward. But when you're looking at it, and to a point that basically Kevin just made, when we look at the data fabric and we look at anything around this, governance is going to be key as we move forward. And we're starting to see more and more importance of the governance infrastructure being required to make sure that we're still talking about a single version of the truth. Whether it's through a data warehouse, whether it's through a data lake, or whether it's through the data fabric, you do have the ability that if you don't cover the data appropriately, you're going to get different answers to your questions. So governance, as Kevin just alluded to, I would agree is a very key component, and very much a lot of organizations are moving, not just from a regulatory perspective, but overall trying to govern their data so it's consistent, the high quality is there, and it can be used by the users.
Understood, Tom. Would you say that governance is one of the top challenges with data fabrics?
Yeah, I think governance is a challenge out there, and whether you talk about a data warehouse, a data lake, or a data fabric, governance is a challenge. And many
Sure.
people are starting to realize that putting the glossaries in place, putting the stewardship in place, and putting overall data governance in place to control data. Because it's all around data quality.
Understood. Okay, moving on to our next question. Kevin, this question is for you. Where are other companies starting from? What capabilities do I need to get in place to get started?
Sure. So what I see as far as where people are coming from, I think a concept that has been in place for some time and a lot of customers have adopted is the concept of a logical data warehouse. So we've had data warehouses for a while, but for a number of different reasons, many organizations have had more than one data warehouse. Sometimes it's around, mergers and acquisitions. Sometimes it's around just geographical location to where the information is. And they've adopted logical data warehouses that brought together that information, much in what Sam was talking around the semantic layer and knowledge graphs. What the difference here is the data fabric is adding that augmentation and the automation to really make things more efficient. It's adding different capabilities around that data catalog to make it more transparent for users to find the information they want to use. So I see a lot of people that they've implemented their logical data warehouse, and now what they're looking to do is advance that, evolve that to the next phase. And that next phase I see as being the data fabric. I agree wholeheartedly with Tom that it's here to stay. And I think anyone that has a distributed data landscape is going to benefit by adopting a data fabric. But also the value that you get to make it easier for the consumer and also easier for the data engineers, the data architects in this whole process is going to be tremendous and a huge value for people. So that's where I see people starting from and sort of evolving to.
Understood. Thanks, Kevin. Sam, we're going to circle back to you. The question is, don't get me wrong, I love the data mesh concept, but will generative AI make the knowledge graph slicing, dicing, and layering efforts obsolete?
As one might imagine, that question has been an elephant in the room at our company, and therefore a lot of thought has gone into it. And obviously, we can't know or guarantee the answer, but the current situation with the generative AI is using these pre-trained data sets to try to get in the right context based on what the user is asking. So the knowledge graph comes along and says, well, I'm fully contextualized and I'm the best input you can have so that you have the best output you have. So it's looking at this point like this could be a boon or a really good situation for knowledge graph technology. And currently we're very optimistic, and we're, of course, like others in our space, we're developing capabilities that use knowledge graph as the fuel, if you will, for generative AI. So we're kind of optimistic right now.
Yeah, they do seem quite complementary
Yes.
in ways. Okay, moving on to our next question. Tom, what about latency of fetching data from diverse data sources into Fabric and then time to analyze and produce insights versus traditional data lake-based data analysis?
Well, that's a mouthful. You are going to have latency in some areas, but it's a matter of the integration and the integration through the metadata and how that is established and how that is set up to be able to bring the data together. Are you going to have latency? Yeah, you're going to have latency whether it's in a data lake, a data warehouse, or just in an application. You potentially have the ability of latency. But you need to be able to. I think the advantage is by bringing that data together to analyze it is going to far outweigh any of the latency that's there to be able to move forward, because you're now bringing data together across the enterprise. That data can change in a very frequent manner. We're now all looking at change data capture, how we bring that data in. So I don't think the latency is really a major issue to be able to bring that forward. But the one issue that's out there is consistency. You've got to have similar definitions in your data across the enterprise to be able to move that forward and to have that consistency so that when you're analyzing the data, it's a consistent definition and consistent terminology.
Understood. Thanks, Tom. Sam, you wanted to weigh in on this one as well?
Yes, thank you.
Oh, sorry.
Thank you, Stephen. I was just going to say two aspects of the latency issue. One is I mentioned W3C semantic web standards. One of those is the query language. But if you dig a little bit deeper, there's an element of that standard that is a protocol for how to manage federated queries. And so the standard itself has measures built in to, I don't want to say overcome, but to mitigate latency issues. And then this is an implementation detail, but the way that our platform helps cope with that and get this robust virtual data virtualization is by applying functions in the AnsoGraph query engine in memory so that it's more dynamic and handles latency better. So there's two things. One is in your implementation, and the other is in the standards that you select. For example, standards that are designed for this kind of data access pattern.
Understood, Sam. Kevin, anything you'd like to add to this question?
Yeah, it's a common question that comes up because you would think that, you're adding a layer in between that it might actually increase latency. But in quite a number of live environments at customer sites, we've shown that we could actually improve the response times, because what you can do is have smart query optimization that, because you're basically gathering this different information or the active metadata around how each system is performing, depending on the workload at a given time, the execution engine is able to optimize the query for that particular run. And it can say, I'm going to push down the query to this particular engine, or bring in a subset of the information. So you're minimizing the amount of information that's going to be moving around the network. But we've shown time and time again that it's more effective, or can be more effective, to actually have this different abstraction layer sitting in between what you're doing around the query, as opposed to just going after a particular environment where if the data is within inside of a data lake and things like that. And then there's other ways to improve it with multiple parallel processing and different things like that that'll allow you to execute these things incredibly quick. So I think that latency tends not to be a problem once you start implementing it and have the system configured appropriately. But it really, I think, always comes up because it's in the back of someone's mind, but very rarely ends up being a problem.
Got it. Kevin, can a data fabric handle structured, unstructured, and streaming data?
To be effective, it really should. Streaming data is being utilized more and more, so it needs to be able to deal with streaming data. The structured data is a given because that's where most of the information typically resides. But also with the popularity of people leveraging different data sources and unstructured data, I think that to be effective, how you implement your data fabric needs to be able to take all of that into account, needs to be able to deal with any data source, any data structure, but also what I refer to as any latency, or another way of saying it is the different way that you're connecting to that information. And I think that it's important that you are able to support all of those different data types to make it so you really are able to leverage all of the information available to the organization.
Understood. Thanks, Kevin. Sam, our next question is for you. Are there any required roles or skills necessary to get started with ONZO or knowledge graph technology in general?
So if you start, let's say if a person started a data fabric project using ANZO as their, I'll say foundation, then you would have to learn what I call knobology. In other words, you would have to learn the ANZO interfaces, but you would not have to learn any new technologies. So your existing personnel and skill sets are able to be successful with creating solutions. And if you start with open source technologies, then you're going to have to understand, and I've been focusing on knowledge graphs with Allen RDF as the foundation for your data fabric. So if you use open source technologies that implement these standards, then you're going to have to understand you're going to have those skills, especially Sparkle, SPARQL. That's the protocol and query language.
Got it. Thanks, Sam. Okay, Tom, question for you, and I love this question. Are there any disadvantages to using a data fabric?
No, there really aren't. I mean, it's an evolution. We've gone from a data warehouse to a data lake, which could also be considered as a lake house. But what you're now doing is really bringing data together. I mean, the only disadvantage is if you don't have consistent definitions throughout your organization. As I think Evan brought up earlier, the distributed data warehouse. If you're going to bring a bunch of distributed data warehouses together, you've got to make sure that you have consistent definition across those, from your data glossary and what you're looking at, so that you're getting to consistent data throughout your organization. But I don't see that there's really any disadvantage. I think the advantages really outweigh it. You can bring data together, and you're now providing really almost real time. Here, I'm getting data to you when you need it, which is really the goal of analytics.
Absolutely. Sam, would you like to add to this?
I would just say I love that answer. And I always tell people we're basically overcoming a problem that we unwittingly created. And what we did was, in my opinion, it was my database, my spreadsheet, my data. And we also assumed that I knew I was right and, my schema was right. So fast forward to our time, we're the generations that are trying to overcome that problem and let the world, if you will, this is kind of the big hairy goal, let the World Wide Web become a queryable database. so that humans can answer questions and collectively we can know what we know. It's not all stovepiped, it's democratized.
Understood. Yeah, I know that removing data silos is a big priority for a lot of companies and IT leaders out there. Well, listen, we're just over the top of the hour, but I have one more question to ask all of you, real quick. Kevin, we'll start with you. If there's one thing you'd like our attendees today to walk away keeping in mind, what would that be?
I think it's really that there's a tremendous value from adopting a data fabric. And if you haven't started to look at what it might take to implement one within your organization, it's probably time that you do. And there's a tremendous amount of resources out there, whether it's from Denodo or many of the other vendors in the space. So it's worthwhile understanding what it would take to implement in your environment and get started. It's an evolution. It's not something of a flip of a switch, but starting to adopt some of the principles will give you some of that value, and then you can continue to evolve into a full-blown data fabric over time as different business needs evolve. So it's not necessarily a big bang that you have to do, but you can start adopting and leveraging metadata more often to then be able to leverage it to improve operations. And you could do it as an evolutionary thing. It doesn't have to require a big investment or a big implementation. You could do it knowing how you want to get there to basically, start taking the steps to get you there.
Understood. Thanks, Kevin. Tom, your final words.
The data fabrics are here to stay. As Kevin said, it's a journey. The reality is anything dealing with data is a journey. There's no stop and a start. You're going to continue to evolve, look into your data, how you want to analyze it, what value it brings, particularly as companies become more data-driven and are leveraging data more as a strategic asset. But you can start your journey small, bring it together, but provide governance and consistency as you go throughout your journey. But the data fabric is here to stay.
Understood. And Sam, I'm going to leave you with the final word.
I love those answers, and I would simply say digital transformation is coming. So think big, start small, scale fast. I'll leave it at that.
Wise words. Well, listen, folks, we appreciate everyone that tuned in. We had a great audience today and a lot of great questions. If we didn't get to yours, as I mentioned earlier, we're going to share the questions with the speakers. You will receive a response via email. But for now, I'd like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise with us. Once again, Sam Chance, Principal Consultant at Cambridge Semantics, Tom Hoblitzel, Vice President of Data Management at DataVeil, and Kevin Bohan, Director of Product Marketing at Denodo. So if you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It will be archived, and you will receive an email from us once that archive is posted. It will likely be up tomorrow afternoon. And again, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on May 31st. We'll let you know if you're the lucky viewer. Well, thank you all for joining us, and we hope to see you again soon.